associate training. And the first thing that you should be aware about is how SDN generally works. So when you look at introduction to SDN, which stands for software defined networking, in SDN, we follow an architecture. So we know that there are lots of network devices which we interact with, right? Including routers, including switches, including firewall, load balancers, IDS, IPS, WLCs, access points, and so many others. All of these devices are manufactured by various networking vendors, right? Including Cisco, Juniper, Palo Alto, Checkpoint, then Huawei, CNR, and so many others. Every organization does provide one or the other way to communicate with the device. If it's a normal router, then on that router you can connect to your admin PC. You can use an application like Putty, mPutty, Super Putty, whatever that is, and then connect your device with a console cable. That console cable will go into the console port, and then you will be able to send or run CLI commands on that device to program it. And then the device will start behaving accordingly. That's not the only way, right? You can also expose your networking device or your router to something, maybe over network to internet, and then someone remotely can sit there acting as admin, still consuming application like Putty, and can communicate with the device using a remote management protocol like SSH, Telnet, or HTTP, and still send communication or configuration onto the box. But apart from just sending configuration so that device starts behaving accordingly, there are a lot of other jobs also that a network device has to do. If you say that we have a small topology where we have router 1 connected to a router 2, router 1 has a LAN segment with some PCs, router 2 also has a LAN segment with some PCs, this being our 192.168.1.0 network, the other being your 192.168.2.0 network. When 1.0 and 2.0 wants to communicate, you will need an intermediate network. Let's say that's 192.168.3.0. So when PC, like when this PC wants to communicate with this PC, the traffic flow will be in a way that the traffic will first go to the gateway. On gateway, there will be lookup in the routing table, and then the traffic goes to the next device. That's where the lookup is performed again, and then the traffic goes to the destination device, and so is the reverse traffic flows. But in this lookup, whenever your router performs a lookup in your routing table to check what all are the destination networks it is capable of forwarding the traffic to, you don't know that or you don't see that. But in the back end, there are a lot of other things that goes on. It can be from calculating the best route. It can be from validating what's the next hop IP address for your destination network, or from building the MAC address table, or from performing a cyclic redundancy check to verify the integrity of the device, performing if there are any errors in the packets, and so many other things that goes on. All of these tasks, apart from just forwarding your traffic, are done with the help of some planes, right? So we know that every device, every networking device has three planes. Every networking device has three planes where the user sits over here and the user interacts with the first one, which is management plane. The second one is control plane. And the third one is data plane. The management plane deals with the components like CLI or GUI, by using which you can interact with the device. Nowadays, CLI is not the only medium through which you can configure a device, right? GUI is also one of the medium used, or that's largely used, I would say. The control plane directly works with CPU, and the data plane works with line cards or interfaces, whatever we say. So user provides its intent to the management plane. Management plane provides the intent to the control, and control provides it to the data. This is how it works. User cannot directly interact with data plane. User cannot directly interact with control plane. Neither your data plane can interact with management plane. So it's a proper hierarchy that is followed. User interacts only with management. Management interacts with control. Control interacts with data. Your control plane builds something called routing information base, and then it works in conjunction with that to ARP to figure out the destination MAC addresses. And then on top of that, your forwarding information base in data plane is built, by using which traffic forwarding is done, right? So RIB and FIB um, communicates together to stay updated about what all are the networks that we can forward the traffic on, and for which destinations what exit interface can be used. That is something which goes on and on and on. Now, because this management plane, control plane, and data plane exist on every single device in a larger environment, if you have maybe 50 devices in a production site, all these 50 devices need to be configured one by one, slowly by your admin in order to bring that network to life. If something goes wrong, everything needs to be checked through by following a certain procedure, although which saves time, but it needs to be checked. And then the proper device needs to be fixed with misconfigurations or so. But how can SDN change this approach? So earlier, the device configuration, management, and provisioning approach is quite slow. Monitoring approach is quite slow. It's device by device, manual, error prone, right? Human doable configs and everything. There is no validator in between who can speed up things. And that's where SDN comes into play. So instead of manual approach, if you look at the SDN architecture, in SDN architecture, you have an admin. That admin communicates with certain sort of certain sort of controller. It can be a controller or set of controllers, depending on the solution that you're using. And then the controller is exposed towards the network or ISP network. And then it is also connected to network infrastructure. That's where your routers, switches, firewalls are there. And then these devices can be configured from your admin. So what happens generally, all these devices will only work with their data plane, and their management plane and control plane will be centralized. So in SDN, the devices give away their management plane and control plane capabilities to certain controller. And then the controller starts acting on behalf of them. So when the admin wants to configure anything, maybe admin wants to configure OSPF on your infrastructure, the admin will provide the intent. Say, hey controller, I want to configure OSPF. Controller says, okay, on which devices do you want to do that? These are the list of devices that I manage. The admin says these and these and these and these. Then controller says, okay, what's the configuration parameters? The admin says, okay, these are the ones. That's my area ID, that's my process ID. These are the interfaces from the set of devices which needs to participate in OSPF. Controller says, okay, let me verify that. Verification done. So controller verifies the configuration or intent specified and creates the configuration on behalf of you. And it also validates it by syntax validations, by functional checks, and by programmatic checks. When all the validations are done, then the configuration will be pushed on the devices. And the configuration will receive the the devices will receive the config, and they will start acting on behalf of the configuration. Now you see, you gain an advantage of configuring multiple devices in one go. You get an advantage of all of your configuration is validated before getting pushed. Remember, Cisco released a survey back in 2021, I guess, that almost 90% of their customers were doing manual config. And out of these 90% of the customers, 70% of the tag tickets that these customers raised had misconfigurations in them. So you imagine how much of wrong configuration or misconfiguration is done by humans. But if these configurations are validated before being sent onto the box, you can imagine the tremendous amount of improvement you would have over your network operations. Right? So such kind of validations and such kind of checks are there in SDN architecture. And when the configurations are being done on the network infrastructure after validation, you tremendously see improvement in your networks. So none of the misconfigurations are going ahead until unless it is passed. There can be logical misconfigurations. For example, when someone configures the wrong IP address, that's not something which by default can be avoided until unless you put a custom check and you can say model that data that it has to be from one of these subnets and so on, which can be done by a tool like NSO or so. But until then, if you're using a ready-made controller, you need to make sure that your configuration parameters are at least correct logically. So this is something that is different from traditional way of managing network. Many people also misunderstand that SDN is something that is going to change packet forwarding techniques. Well, not. SDN is not something that changes the way how packages are packets are forwarded. SDN is minute. Yeah, SDN is something that actually improves how networks are managed. So if you and there are multiple types of SDNs. There is pure SDN in which the devices will completely give away their management plane and control plane so that you cannot configure these devices from CLI at all. For example, when you're in SD-WAN solution, when your WAN has become part of the solution, part of the fabric, you cannot do any configuration on the devices directly. You have to do it via the controller, right? So that's called as pure SDN, where the control plane and management plane is completely given away. Then you have something called hybrid SDN. Hybrid SDN is something where the control plane, data plane, and management plane will be retained by your device only, but the configurations will be done from a central source of touch. And that's where coding and programming comes into picture. So we try to configure multiple devices in one go by building custom logics. The job that controller might do on your behalf. You try to do it by your own by using Python, by using other programming tools, and still achieve the results of pure SDN by keeping the model of your SDN as you can say hybrid SDN. So that is something which you can achieve. And in this, the communications that happens between you and the controller and the devices are divided into two parts like this. So whenever there is any communication that happens between admin and the controller, we call that as northbound communication. Remember that, okay? This concept is something that you will require in your DevNet Expert also. And whenever there is a communication that happens between controller and the infrastructure, then this communication is called as southbound communication. Okay, so you need to understand that whenever you are communicating with the controller, it's northbound. And when the controller is communicating with the infrastructure, it is southbound. We, in our case, will be modifying, will be using various tools, sometimes to directly push configuration. So if we try to build up Python scripts on this admin machine and directly push it to the devices, then we are not using controller, we are using hybrid SDN. But if you are communicating with a controller like vManager using REST API or so, then you are programmatically communicating with the controller with northbound and then specifying your intent, which then will be, you can say, which then will become actionable items for your controller using southbound. Same happens for NSO, same happens for Catalyst Center, same happens for Cisco service provider tool called Crosswalk, same happens for security tool called FMC, Firepower Management Center, same happens for WebEx, same happens for COCM, same happens for UCS Director, anything that Cisco has in its portfolio, which has the capability of acting as controller. And that's something which differs how the thing works.